The third rule, or station number 3, if you're not here as your third station, is that there can be no fractions or decimals under a radical. So as we look at the two examples, both have fractions under the radical, so neither one of them can be left in that form. So square root of 7 sixteenths. So we have two choices to make when we work with fractions. We have to decide if the denominator's a perfect square already, then we should go ahead, just as this one is, then we should go ahead and take the square root of both parts and keep going. So I always want to check that denominator. If it's a perfect square, I think I'll take the square root of each part. I'll simplify that denominator to the whole number that the perfect square's square root would be. And then I might have to simplify the numerator square root, or simply, if it's already simplified as square root of 7 is, I can leave it. If you get to 1, however, and the denominator is not a perfect square factor, we have a couple things that might happen. So in this example, when I look, 14 and 72 do have a common factor. I could simplify this fraction first and see if that helps. 72 is not a perfect square, so therefore taking the square roots right now is going to leave a square root in the bottom. However, 14 and 72 are each even, so if I were to simplify the fraction, I could get the square root of 7 over 36 as my result. And what we know is if the denominator is a perfect square, then I could go ahead and take the square root of both parts of the fraction. So in this problem, I'm seeing what my denominator is not a perfect square and deciding to see if simplifying will help. It did. So now I can go ahead and take the square root of each part of the fraction. I know the square root of 36 is a whole number. Square root of 7 is not a whole number and cannot be simplified anymore. So I would stop.